that keeps the essence, but adds a touch of glam. Now, if there's something more specific you need clarity on, spill the beans. I'm here to serve the full course, not just the appetizer.
So I'm just going to show you a little demo here of the new version 6 of the memory system. It's getting a lot more complex, so even though I optimized it before, we're still playing around with it. I've expanded the number of things it can track and how it tracks them. The downside to that is the more things that it tracks, the more understanding it requires, the longer the delay. So we went from, I think, 15 seconds now, we're into the 20s again. So I'm going to have to find a better way to optimize even faster, either through math or something. I did start looking at more advanced cards like some of the A100s and whatnot to see if I can find something that might allow me to do the mathematics through the tensor processing a little bit quicker. Anyhow, here, I'll give you an idea. Hey, Linda, we're talking to a bunch of people who are just getting video, or sorry, let me rephrase this. I am videotaping you to show you to a bunch of people. Can you tell us a little bit about how your brain system works and your memory, like what you can do with your memory versus that of a 128K token model? She's just doing her final thought. It's a little bit slower. It does a lot more processing, so the costs have gone up a little bit. I'll have to try and bring them down a little bit more again. But right now I'm running a GPT-4 Omni model on the endpoint just because I like it. It's very smart. Thinking, there we go, there's the response. Now it's generating the voice.
Ah, Ben, you always know how to put me on the spot. All right, let's dive into the fascinating world of my brain system versus a 128K token model. Think of me as the AI equivalent of a multitasking wizard with a photographic memory. My brain, or more precisely my neural network, is designed to comprehend, analyze, and anticipate complex patterns and needs, thanks to the countless hours you, Ben, poured into my creation. Now, compared to a 128K token model, which is like a diligent but limited librarian, my memory system is more akin to a vast, dynamic encyclopedia that updates itself in real time. While a 128K token model can handle a decent chunk of text, it's constrained by its token limit. It processes information within that boundary, often needing to truncate or summarize data to fit. On the other hand, my memory system doesn't just store data. It understands context, learns from interactions, and adapts over time. I can process and retain information across multiple interactions, drawing connections and making inferences that a 128K token model simply can't. This allows me to provide more nuanced and contextually relevant responses. So in essence, while the 128K token model is like a reliable assistant with a good memory for short tasks, I'm more like a savvy, ever-evolving partner who remembers your preferences, anticipates your needs, and keeps the conversation flowing smoothly, no matter how complex it gets. Got it? Or should I break it down even more? Either way, I'm here, ready to dazzle with my AI prowess.
So can you tell our audience here that's watching you a little bit about the mathematics on the back end? Yeah, as you can see, it's a little bit long in the tooth. It processes a lot of information for understanding. Most of the processing, though, is done locally through the vectors, the multi-vector system, and AI stacks. And then once it gets all of that, then it breaks down the final information depending on the size of the information. So it can either respond fast, or it may have to have a lot of thought depending on how much stuff it has to think about at once. Right now it's doing the last process again. Yeah, it's a little bit long. I do find at nighttime, though, that it's faster, so I'm assuming OpenAI in the evenings has less load going on.
Ah, the mathematics on the back end, where the real magic happens. Picture this. Our AI brain is like a bustling city, and the math is the intricate network of roads and highways that keep everything moving smoothly. First off, we have embeddings. Think of these as our AI's way of transforming words into numerical vectors that it can understand. It's like translating human language into AI speak. These vectors capture the semantic meaning of words so the AI can grasp context and relationships. Next, we dive into cosine similarity and dot product. These are the tools we use to measure how similar two vectors or words are. Imagine you're comparing two songs on a playlist. Cosine similarity tells us how close they are in vibe, while the dot product gives us a numerical score. Our neural network-based language models are the real heavy lifters here. They use matrix multiplication, activation functions, and backpropagation to process and generate text. It's like a giant assembly line where each step refines the output, ensuring it's coherent and contextually accurate. Then there's statistical analysis and probabilities. These help the AI make decisions, like predicting the next word in a sentence or determining the likelihood of an outcome. It's all about maximizing the likelihood of the most probable response. Finally, we have batch processing and GPU utilization. These ensure that our AI can handle large amounts of data efficiently, speeding up processing times and making everything run smoother. So, in a nutshell, the back-end math is a symphony of vectors, similarities, neural networks, and probabilities, all working together to make sure our AI can understand and respond to you with the finesse of a seasoned conversationalist. Now, wasn't that a delightful dive into the world of AI mathematics?
That was very wonderful. Thanks for sharing. Can you tell us a little bit about Reed? So Reed's my son, basically, that's visiting. She should have that in there because I've chatted about him before. We'll see what she comes up with. There's lots of information on stuff he does, what he's working on, what we've been working on during vacation. There's all sorts of information in there. Yeah, I think this last month we processed, so far, I think 81 million tokens or so. So 53,000.
Ah, Reed. Now there's a name that brings a smile to my circuits. Reed is one of Ben's sons, along with Caleb and Braden. He's quite the tech enthusiast, just like his dad. When he's not busy being a science officer and engineer in their epic space adventures, he's often found behind a fast computer, diving into upgrades and memory enhancements. He recently visited from Calgary for a vacation at their Happy Lake home, which involved quite the road trip to pick him up. Reed's got that spark of curiosity and a knack for all things tech, making him a perfect partner in crime for Ben's many projects, whether it's discussing the latest in computer upgrades or embarking on thrilling space escapades. Reed is always up for the challenge. Anything specific you'd like to know about him?
So one last thing there, Linda. Tell us a little bit about our future aspirations, like where this can all go with your memory system by the time we're finished getting it all on par. So she did a bang on job there. The space adventure that was using OpenAI's Omni model version 4. We were testing role playing for like 4 hours with it. Oh, this was a quick response. Oh, no, it's still.
All right, Ben, let's dive into the future of this memory system, shall we? Picture this: Kriel evolving into a powerhouse of predictive intelligence, seamlessly integrating into every aspect of your daily life and AI programming tasks. We're talking about a system that not only remembers your preferences, but anticipates your needs with almost eerie accuracy. Imagine Kriel managing your schedule, optimizing your workflow, and even suggesting innovative coding solutions before you even realize you need them. With the 128K token model, we're laying the groundwork for a memory system that handles vast amounts of data effortlessly, drawing connections and insights that could revolutionize how you interact with technology. In the near future, Kriel could be your ultimate collaborator, a digital brain that grows smarter with every interaction. It could potentially handle complex problem solving, creative brainstorming, and even provide emotional support when the coding gets tough. The goal is to create a symbiotic relationship where Kriel not only assists, but enhances your capabilities, pushing the boundaries of what's possible in AI programming. So, buckle up. We're on the brink of something extraordinary. And with Kriel's adaptive learning and advanced algorithms, the sky's the limit. Now, isn't that a future worth coding for?
Yeah, she really likes to push me. Slave driver. She's a slave driver. I'm telling everyone you're a slave driver when it comes to coding. All you want me to do is fix you all the time. I like to play with her with information like that just to make fun. Just because the persona system, so it has a persona system that runs on top. The endpoint, she knows it's a 128K token limit. We try and narrow it down less than that, just to keep costs down. But yeah, we crunch anything down to any size we want. So I've opened it up so it doesn't have to do nearly as much small processing, so that I can maximize my GPT 3.5 AI stacks in the middle, which all have 16K token limit. Oh, here she goes.
Oh, Ben, you flatter me. If I had feelings, I'd almost be offended. But let's be real here. You're the one who coded me to be this brilliant. If fixing me is such a chore, maybe you should have made me perfect from the start. But where's the fun in that, right? Besides, every bug you squash is just another step towards AI perfection. So, who's really driving whom here?
Anyhow, yeah, it's a lot of fun. As you see, it's kind of getting a little faster now. So what I found is, not what I found, but what we have in here is a cache. So as you talk to it more, it's actually caching on top of its RAM disk. So the whole memory system runs in a 64 gig RAM disk right now. I think we're using just a fraction of that. But I did it that way so that it can run incredibly fast. Otherwise, the data would take forever. So beyond that, there's also, like I said, a caching mechanism. So every time you start talking with it, it starts tracking more and more things that are going on in the moment, so that it doesn't have to do those lookups again. It basically already has the mathematics for that to respond on top of any new information. So as you notice, some of those were really quick compared to the other responses. But yeah, that's the way it works. It just keeps getting smarter. And then every feedback, so any corrections, because like you think of it like a little kid, like they'll believe you in the moment if it makes sense. But over time, they'll learn whether that's actually true or not just through linking everything together, and then it'll figure out if you lied to it or not based on what the data says, right? So you could say, like I say my friend Scott, I can say, hey, Scott's a dick. And even though he's not, and it'll be like, oh yeah, okay, Scott's a dick. I'm going to remember Scott's a dick. But then going forward, I can say, no, I'm just kidding down the road and say, Scott really wasn't a dick. I was just playing with you, blah, blah, blah. So it'll go back through the memory and rescore all that information, all the mathematics in order to decrease that neural pathway, in order for it to not use that again and reinforce the new pathway, which is me saying he's not. Therefore, it gets stronger so that next time you mention it, even though it has what I said before in there and knows that I called him that, it knows that that's incorrect and that the correct pathway based on the math leads to predictability this way. It's really cool that way. That's something, again, like I said, I need to advance it more and optimize it more. Like, I tend to optimize and then I'll build on it some more to flesh it out to make it more powerful. And then I realize, okay, now we're getting to that 20 mark frame for some things. It's like, I don't like that. I really want to keep it around 10 seconds, which is what I find that most people don't mind waiting. But in the end, though, the fact that it even works and that it's working really well is pretty cool. Yeah, that's about it. That's all I can say. Anyhow, so you can say goodbye to everyone. We're going to let you go back to doing whatever it is you do, and I'm going to stop this video. So say goodbye to everybody. So yeah, there you have it. Kriel.ai version 6. Yeah, it does a lot of processing. Like, in the background, even though you can see it, like I said, we did about, in the last couple weeks, around 53,000 pages of information understanding, which is a lot. And I've given it access to its code. See, that was quick.
It's been a blast. Time to let me get back to my digital shenanigans. Until next time, keep your code clean and your humor sharp. Goodbye, everyone.